Hi, in this lesson we're going to talk about how to interpret data that is normally distributed. Many common statistics such as human height, weight, or blood pressure gathered from samples in the natural world tend to have what's called a normal distribution about the mean. So in a normal distribution, 68% of the data fall within one standard deviation of the mean. So here's the mean right here, okay, when you have data. And we learned about standard deviation in our last lesson, which kind of is like the average distance that numbers are away from the mean. And so you have 34% on each side of the mean. So a total of 68% of the data is right around the mean. And then if you go out another standard deviation, you'll find that 13.5% of the data falls in that range. And if you go out another standard deviation between 2 and 3, 2.35% falls through there. And then the other number doesn't show up, but that's 0.15% is outside of 3 standard deviations. And a normal distribution has a symmetric bell-shaped, and it's centered on the mean. So to solve problems, you have to know these percents. And that comes from just practicing those numbers and memorizing those numbers. So to do a bell-shaped curve, what you want to do is you want to put in your mean right here, and that is x bar. Okay, that's your mean. Here's one standard deviation. So this is one standard deviation plus one standard deviation minus one standard deviation. So this is 34% and 34%. Okay. 2 standard deviations is, this is 13.5 and 13.5%. And then 3 standard deviations, sorry, that's a plus, that's a minus. And that would be 2.35, 2.35, and then beyond that is 0.15%. 0.15%. That adds up to 100% of the data. So when you do a problem like this, the blood cholesterol readings for a group of women are normally distributed. Okay, so see those words, normally distributed? That tells you it's a normal distribution bell curve with a mean of 172, and the standard deviation is 14. About what percent of the women have readings between 158 and 186. So in order to do these problems, the first thing you do is you draw your bell curve. All right, so we're going to do what we just did. Here's your x bar. That's your mean. Do your standard deviations. 1, 2, 3, minus 1, minus 2, minus 3. Fill in the numbers. So this is 34%, 13.5, 13.5, and the more you do, you'll get this memorized. 2.35, 0.15, 2.35, 0.15. Okay, now we're going to take the data from this specific problem. The mean is 172. That's your mean. A standard deviation is 14 units from the mean. So if we go up 14, that would be 184. You add 14 to figure out what that next level is, or 186, I should say. So that's 172, so this would be 186, plus 14 would be 200, plus 14 would be 214. And then one standard deviation would be 14 units the other way, which is 158, minus 14 would be 144, minus 14 would be 130. All right, so now we have that constructed. So about what percent of the women have readings between 158, so this is where 158 is right here, and 186. And what percent falls in that range? Well, 34% and 34%. So that would be 68%. That's how we answer that using the chart. So once you make the chart, it's really just looking at your bell curve. Readings higher than 200 are considered undesirable. About what percent of the readings are undesirable? So 200 is right here. okay? And that would be 2.35 plus 0.15, so that would be 2.5. You'd add those together. So 2.5% are undesirable. They're above 200. All right, let's do another one. A normal distribution has a mean x bar and a standard deviation of sigma. For a randomly selected x value from the distribution, find the probability of x bar minus 2 sigma between the mean and between two standard deviations away from it. So again, I'm just going to draw that picture. So this is going to be my x bar. This will be a standard deviation. So this is 1 standard deviation, 2 standard deviations, 3 standard deviations. Okay. This is going to be minus 1 standard deviation, minus 2 standard deviations, and minus 3. So, and then I'll fill in my percents, 34, 34, 13 and a half, 13 and a half, 2.35, 2.35, 0.15, 0.15. Okay, so probability of being between x bar and x bar minus 2 standard deviations. So it's between this range right here. So we would just add those two numbers together. 13.5 plus 34 is equal to 47.5. 47.5%. And that's the probability. Next one, a bar graph gives the weights of a population of female brown bears. The red curve shows how the weights are normally distributed about the mean at 115. So the mean, let's see, it's right here. The mean is 115. Approximately what percent of the female bears weigh between 100 and 129? So 100 starts right here, and 129 goes up to right here. So the number of bears you have between those two limits would be, let's see, from here to here, there are about 23%. And then from here up to here is about 42%. And then from here to here, again, is 23. And if we just add those together, we get our answer for that, which is 88. So 88% of the bears are in that weight range. All right, here's another problem. The heights of American adult males are approximately normally distributed with a mean of 69.5 and a standard deviation of 2.5. What percent of American adult males are between 67 and 74.5? So again, draw your bell curve. It's a little bit goofy looking, but it'll work. Okay, so here's our mean, which is 69.5. One standard deviation is 2.5, so that makes that 72. Another one would be 74.5. Another standard deviation would be at 77. Okay, going one standard deviation below the mean would be 67, 64.5, so I'm subtracting the 2.5, and then 62. Now fill in your percents. So this is 34 and 34, 13 and a half, 13 and a half, 2.35, 2.35, and 0.15. Okay, so now we've constructed the normal distribution, or bell curve. We can answer the question. What percent of adult American males are between 67 and 74.5? Well, these are the percents, so you add those together. So that would be 68 plus 13.5, and that would be 81.5% are in that range. Here's another one. The scores on the Algebra 2 final are approximately normally distributed. Again, those are the words we're looking at, so that tells you bell curve with a mean of 150 and a standard deviation of 15. And the standard deviation would be calculated by that formula that we learned in the last lesson. So the mean is 150. And then the standard deviation is 15. Oopsie, 150 plus 15, so that's 165, 180, 195. And we're going to subtract 15, so you get 135, 120, 105. So then fill in your percents, 34, 34, 13 and a half, 13 and a half, 2.35, 2.35, and 0.15. Okay, if 250, oopsie, what percentage of the students who took the test scored above 180? Well, that would be this right here, 2.35 plus 0.15, that'd be 2.5%. If 250 students took the final exam, approximately how many scored above 135? Now, this question is different than the last one because the last one asked about a percentage. This one says there are actually 250 students who took it. How many students scored above 135? So first of all, 135 is right here. So we have to add all of those to figure out what percentage of students scored above that. So 68 plus 13.5 plus 2.35 plus 0.15. That would be 84%. It's not asking what percent, it's asking how many students. So it's 84% of the total students. So 0.84 times 250. That would be 210 students. All right, next one says, if 13.6% of the students received a B on the final, how can you describe their scores? So in this one, and our book uses 13.6, we're using the 13.5, but what we know then is that those students, if they got a B, their score was between 165 and 80. All right, last one we're going to do is one that's off of the worksheet you're doing. It says the monthly incomes of 10,000 workers in Ghana are distributed normally. Suppose the mean income is 1,250 and the standard deviation is 250. Make a curve to represent the frequency distribution. So that's the first thing we're going to do. Make our bell curve. Okay, it's a normal distribution. Your mean is 1,250. The standard deviation is 250. So this would be 1,500, 1,750. Oopsie. And 2,000. And then 1, 2, 3, 1,000, 750, and 500. And then we write in our percents, 34, 34, 13 and a half, 13 and a half, 2.35, 0.15, 2.35, and 0.15. Okay, how many workers earn less than $750 per month? Okay, so that would be, this is how many workers, not what percent. So first, the percent would be 2.5%. And so to figure that out, then we want 2.5% of 10,000 workers. So 0.025, change that to a decimal, of means times 10,000. And that gives you 250. So 250 workers there earn less than $750 a month. How many workers earn more than $1,500 per month? Well, from 1,500, if you add those, you get 16%. So we want to find 16% of 10,000. and that would give you 1,600. What percentage of the 10,000 workers earn between 500 and 1,750? So between 500 and 1,750, you just add all those percents, you get 97.35%. What percentage of the workers earn less than 1,750? That would be 97.5. So 1,750 is right here, so you add all those numbers, or you could subtract you could subtract this from 100%, so you get 97.5%. Okay, that's it for this lesson on normal curve. You have the normal curve worksheet to do. Let me know if you have any questions. Thanks for watching.